Single player games are cool, but you know what's cooler than a single player game? Two single player games, specifically ones that can connect to one another. This at its core is essentially what a network game is, just a single player game running on different machines with a few synchronized parts. Code you write for single player games will work the same as it does in multiplayer environments. We just get to access a few more properties that allow us to implement a few additional features. This tutorial series will guide you through all the essentials you need to make working multiplayer games in Unity. We'll also cover some essential networking topics, setting up game lobbies, connecting to Steam, and a few other interesting things you might need during development. Now, although this series is focused around the package FishNet, you'll be able to translate most of your learnings to other networking packages like Mirror, PerNet, Netcode for game objects, etc., because fundamentally all these packages share similar standardized behavior. Now, to make multiplayer games in Unity, we require a multiplayer networking framework, which provides us with the necessary core systems that allow multiple players to communicate, synchronize game states, manage objects, and send method calls to one another. It abstracts the low-level networking so developers can focus on gameplay logic rather than the nitty-gritty of packet handling or connection management. The package we'll be using today is FishNet. It's free and gives us enough control to be able to execute anything we need. It's important to note that sometimes these frameworks get mixed up with what's referred to in network games as transport layers. The transport layer handles how the data is being sent and its latency, and we won't have to look at that too deeply at the moment, but in the future we'll address this and how we can change the transport layer of our game to, for example, rely on the Steam services or Epic Game Store. Let's begin by creating a new project. Open up the new project window and select the Universal 3D Render pipeline to follow along with the tutorial. Select whatever name you'd like and click Create Project. Now, navigate to the Windows button at the top of your screen. Click on Package Management and then Asset Store. Once open, search for FishNet and add the free version to your library. Return to your Unity project again and open the Window tab. Go to Package Management and My Assets this time. Search for FishNet in your assets and download the free version and import it into your project. Now, from either the link below or by searching Parallel Sync, open the GitHub page. Navigate to the releases and download the latest Unity package and import it into your project. Now that we installed both Parallel Sync and FishNet, we can start with the tutorial. Start by searching for the Network Manager in your Assets folder and drag and drop the prefab into your hierarchy. This is what controls the connection to other players, spawning different players, and other network behaviors. Let's start with making a basic platform for the players to step on. I'm just going to create a cube, position it at 0, 0, and resize it to be 20 lengthwise and 20 widthwise. This way the players can walk on that. I'm going to reposition our camera so that it's facing the positive z-axis. Here at the top we can see that blue line isn't showing. And we just have to click on the camera and click Ctrl-Shift-F. Now, I'm going to make a basic player prefab out of a capsule. I'll just add a capsule component like this, and I can position it on our new floor that we just made. I'll go to Add Components and search for Network Transform. The Network Transform component is provided to us by FishNet, and what it does is it essentially synchronizes all these transform variables, including position, rotation, and scale. We can choose which parts we want to synchronize. For example, if you don't want to synchronize the scale and save on your network bandwidth, we can turn that off. For now, we'll just keep everything on. You can also see that the network object script was added automatically. This just tells FishNet that this is an object with network behavior that may or may not need to be synchronized at some point. Let's make our own movement script for the player now. I'm going to return to my Assets folder, click Create, Mono Behavior. I'm just going to call this script Player Movement. Now, I'm going to delete the start method because we won't have any use for it for now. And I'm going to extend network behavior rather than mono behavior. This will give us the additional functionality we need to be able to interact with FishNet. And at the top, I'm going to type using fishnet.object. I'm going to create a public float move speed variable and then set that default value to 5. This will control the player's speed later on. Now, to get the input from the regular WASD, we can use the input.getAccess methods. And I'm going to store those both in 2 floats. One for the horizontal input and one for the vertical input. Once we have those done, I'm going to create a vector for the movement direction that we can use to move the player. Now, to make sure that this movement direction vector isn't faster on any diagonals, we're going to normalize it if it's greater than 1. And finally, we'll update the transform of the game object to match the new movement direction. We'll take the original move speed that we defined, multiply it by our new move direction variable, and then multiply all of that with the time.delta time to make sure that it's frame rate independent. Now let's return to our project view and click on the capsule we made earlier. Let's rename this to Network Player and drag and drop our new player movement script. Now we'll save it as a prefab by dragging the Network Player into our project folder, and we'll delete its instance from the game. Let's open the Network Manager and navigate to the player spawner and add our new Network Player to the player prefab. Now, to get this to work, we need to make sure we're on the right active input handling system. Unity currently has 2 input systems, the new and the old one. The script we just created relies on the old one, so we have to switch to that. Let's click Edit, Project Settings, and open the Player tab. Under Other Settings, we'll scroll to Active Input Handling and set it to both. Now we'll make use of our other package we installed, ParallelSync, which will allow us to open multiple editors locally so we can test out our multiplayer functionality. Begin by clicking the ParallelSync button at the top, and then clicking Clones Manager. You can drag this window wherever you'd like, and then click Create New Clone. Once you created the new clone, click Open in New Editor. Now we have 2 project folders open, one with our regular name and one with the Clone0 name attached to it. Make sure that our sample scene is saved before we open this one. Click Play in our regular game, and without worrying too much about what these mean for now, we'll click Start Server and Start Client as well. Make sure you can move the player that was just spawned. Let's go back to our other client and click Play as well here. But rather than clicking Start Server and Start Client this time, we'll just click Start Client. Now we can see 2 players have spawned, but when we try to move the players, both players move. At least on this screen. If we were to do the same on this client, both players would move again. Now, to fix this, we can return to our player movement script and update it by adding this line. We'll check if the player controlling it is the owner of this object, meaning the player spawned this specific object. If that's the case, we'll run this script here, and we'll move this inside the if statement. indented. We'll save this new script, and we'll try replaying the scene now. We'll click Start Server and Start Client on our main game again. And then we'll replay our other client as well. Now, when we move one player, the other one doesn't move. So this way we've learned that we can use network transforms to synchronize transform variables like scale, position, and rotation. And we can use script and ownership to decide whether or not a player can move or handle something.